Bismillahirrahmanirrahim. Question number 2. Use quotient rule to find out the derivative of the following function. Question 2, part A, y equals to 3x minus 5 over x minus 4. Differentiate with respect to x using quotient rule. D by dx of y equals to d by dx of 3x minus 5 over x minus 4. Here we get dy by dx. Now applying quotient rule is that first take this denominator and take the derivative of numerator minus write the numerator and take the derivative of denominator whole over denominator square. This is quotient rule. Denominator derivative of numerator minus numerator derivative of denominator whole over denominator whole square. This is quotient rule. Now x minus 4. Now look, the derivative of 3x is 3 and the derivative of minus 5 is 0, so we don't write it. Now here 3x minus 5, here the derivative of x with respect to x is 1 and the 4 is 0, so just write 1 here and x minus 4 whole square on its place. Now multiply this 3 with x, we get 3x minus 12, and here we get minus 3x, minus into minus plus 5 over x minus 4 whole square. Now this 3x cancel with 3x and 12 minus 12 plus 5 we get minus 7. Minus 7 over x minus 4 whole square. This is the answer. We have differentiated it by quotient rule. Now part B, y equals to 2 over 3x minus 5. Solution: differentiate with respect to x using quotient rule. D by dx of y equals to d by dx of 2 over 3x minus 5. Here we get dy by dx, and here denominator 3x minus 5 into derivative of numerator minus numerator into derivative of denominator, which is 3x minus 5 over 3x minus 5 whole square. Now look, the derivative of 2 is 0, so when 2 is multiplied with this we get 0, minus 2, the derivative of 3x is 3 and the 5 is 0, so just write 3 here and 3x minus 5 whole square. Further we get minus 6 over 3x minus 5 whole square, the answer. Now part C, differentiate. Solution: differentiate with respect to t. D by dt of f of t, d by dt of t square plus 1 over t minus 1. So here we get f dash of t or f prime of t, and here denominator into derivative of numerator minus numerator into derivative of denominator over denominator whole square. Now t minus 1, here the derivative of t square is 2t and the 1 is 0, so leave it. Here t square plus 1, derivative of t with respect to t is 1 and the 1 is 0, so just write 1 here, and here t minus 1 whole square. Now multiply this 2t with t, we get 2t square, 2t into minus 1 we get minus 2t, and here minus t square and minus 1 over t minus 1 whole square. Now 2t square minus t square, we get t square minus 2t minus 1 over t minus 1 whole square. This is the answer. Part D, try by yourself. Now part E, y equals to 5x plus 6 over under the root x. So it can differentiate with respect to x using quotient rule. D by dx of y equals to d by dx of x 5x plus 6 over under root x. Here we get dy by dx, and here denominator into derivative d by dx of numerator minus 5x plus 6 into d by dx of this under root x can be written as x power 1 over 2, and here denominator square. Now here this under root x can be written as x 1 over 2, and the derivative of 5x with respect to x is x, and the 6 is 0. Here 5x plus 6, and the derivative is, take this 1 by 2 into product x power 1 by 2 minus 1, and we know that then again derivative of x is 1, so you can write it here. Here the square root cancel with this, we get x. So here we can write it as 5 x power 1 by 2 minus here 5x plus 6 into 1 over 2, and here take the LCM 1 minus 2 over 2. 2 ones are 2, 1 minus 2 over 2 whole over x. Now we can write this x common here, take it 1 over x. Here we get x power 1 over 2 minus 5x plus 6 and write this 1 over 2 here. Now here remains 1 minus 2, we get minus 1 over 2. In the next step we can write it as 5x power 1 over 2 minus, here we can write it 5x plus 6 over this 2, and shift this x 1 over 2 down, it will become x power plus 1 over 2. Now take the LCM this, multiply this 2 here, we get 10, and x 1 over 2, x 1 over 2, we get x minus here 5x plus 6 over 2 x power 1 over 2. Now x, and also multiply this 2 x power 1 over 2 and write it as 10x minus 5x and minus 6 here. These two are in multiply, so look here, x into x power 1 over 2, we can write it as 1 plus 1 over 2. Further we can write it as 2 ones are 2, 2 plus 1 over 2, 3 over 2. So we can write it as x 3 over 2, and here 10x minus 5x, we get 5x and minus 6. So we can write it as 5x minus 6 over 2 x power 3 over 2. This is the answer. Try part F by yourself. Now part G. Part G1 is f of p equals to 2p plus 3 into 4p minus 1 over 3p plus 2. First multiply these two and then apply quotient rule. So by multiplying these two, we get f of p equals to 2p into p, we get 2 times 4, 8 p square minus 2p, 3 4s are 12p minus 3 over 3p plus 2. Further we can write it as 8p square here plus 10p minus 3 over 3p plus 2 f of p. Now differentiate with respect to what? With respect to p. So we can write it as d by dp of f of p and d by dp of 8p square plus 10p minus 3 over 3p plus 2. Now look, we can write it as f prime of p equals to, here denominator into d by dp of numerator, which is 8p square plus 10p minus 3, minus numerator 8p square plus 10p minus 3 into d by dp of 3p plus 2, 3p plus 2 whole over 3p plus 2 whole square. Now look, 3p plus 3, this is 3p plus 2, okay, 3p plus 2. Here look, the derivative of p square is 2p, so 2p into 8, 16p, and the derivative of 10p is 10 and the 3 is 0, minus 8p square plus 10p minus 3, the derivative of 3p is 3 and the 2 is 0, so only 3, and here 3p plus 2 whole square. Now multiply and simplify. So 16 3s are 48 p square, 16 2s are 32p, 3 10s are 30p, and 10 2s are 20, minus here 3 8s are 24p square, and minus into plus minus 3 10s are 30p, and minus into minus plus 3 3s are 9 over 3p plus 2 whole square. So f prime of p equals to, we get here 48 minus 24, we get 24p square plus 32p plus 29, and we get here 3p plus 2 whole square, the answer. Part H, g of x equal to x cube plus 1 over 2x plus 1 into 5x plus 2. First of all multiply these two, we get this, and now apply quotient rule and solve it.